Good afternoon, everyone. Thanks for joining. We appreciate the time that you're going to give us to share with you some lessons learned in risk-based vulnerability management. This is a case study where we're going to focus on one particular customer, but the lessons are pervasive every time that we've deployed RBVM in any of our customers. And it's not about what we've learned as a development company, but what we've learned in helping people solve this very complex problem. Our speaker today is Kevin Saucier. And Kevin has more than 20 years in IT security and consulting, including 15 specifically in security and compliance. Kevin led our compliance consulting practice for many years. And he converted over to North Star, and he's spent the last 8 years helping folks solve risk-based vulnerability management. In addition to this, Kevin is also an expert at barbecue and smoking various types of meats. So if you ever need help with that, he's another good resource to reach out to. With that, I'm going to turn it over to Mr. Saucy.
All right. Good afternoon, good morning, good evening, wherever you happen to be. So for this talk, we're going to, just to give you a little idea of agenda, I'm going to do just a little tiny bit of introduction just to kind of set the table properly for understanding this case study. We'll talk, the bulk of our time will be talking about the specific case study and the actual implementation and, you know, all the lessons learned and challenges that we ran into. We'll have a little recap there just to sum it up, and then we'll have some Q&A, which hopefully this talk will spur some interesting questions. So as far as introduction to the topic, so one of the things when we talk about RBVM, it's been a increasingly important topic. It's gotten a lot of traction in the last couple of years, and mostly it's gotten the traction simply because it's expanding our concept of vulnerability management out to include the idea of context, that, you know, the general idea that risk can only be, can only really be understood once we actually understand the intersection of not only vulnerabilities, the threat data that's coming out from the real world, but then also the asset context that's there. And in that vein, to give you a kind of a specific scenario there, there are instances where when we're trying to solve, when we're making decisions about vulnerability management, we'll have vulnerabilities out there, things like SEV9s that are out there, and we'll have SEV5s, we'll have different types of vulnerabilities. But one of the challenges is, and the question that kind of comes up is, what do I fix first? I only have so much time to fix issues in the environment. So how do I triage this process? And what's interesting is that in most environments that we found that are, that haven't really started down this RBVM kind of thinking, the SEV9 itself is just based upon its severity is going to get fixed first. The SEV5 maybe will be fixed later. Oftentimes, depending on the volume, may not actually ever get fixed. But as soon as we start looking at the context involved, we start understanding that, well, yeah, it's a SEV9, but it exists on a testing QA server that has no known exploits. Whereas that SEV5 might actually be on an important machine, production, internet facing, actually being exploited in the wild. So customers looking to go down the road, or organizations, looking to go down the road for RBVM, this is the problem that they're really trying to solve. Now, there's a few things here. One of the things that when we talk about trying to solve this issue, what becomes critical is being able to transition away from this idea of just relying on vulnerability data. So I kind of alluded to this previously, but there's an evolutionary process of, we start looking at things like threat intelligence and being able to kind of reorient our view of those vulnerabilities based upon threat intel. And then ultimately being able to fold in that idea of context to really give a defined view of the organization, but then also a very refined view of the problems that are there and what really needs the attention right now to go get fixed. So this is really what, when we talk about this case study, this is what this particular customer was looking to achieve in their environment. Now, a couple of concepts here that are also going to be important. One is within North Star as a product, we do have the idea of a super list, but what that really is going to do, that has to deal with our data model and how we are structuring data that we're going to use, and how we're ultimately giving, laying a strong foundation for customers to be able to do RBVM properly. So I'm going to talk about this in more detail, but I wanted to introduce that term to everybody. Some other kind of specific things when we talk about RBVM. Number one, when we talk about asset context, one of the things that always challenged us was asset criticality. It tended to be a very flat way of viewing an asset. It also tended to be very manual. But when we start looking at RBVM, our goal here is really to evolve this into more of a business importance score. So being able to capture all of the different facets of what makes an asset critical. And in fact, the data likely exists. What we found is most customers, typically when they're looking to expand this idea of context, that information exists. It's just not in places that they typically think to look. And one of the last kind of conceptual thing to set the table is you're going to hear me use the term exposure quite a bit. We here at North Star, we talk about exposures because very often there are vulnerabilities that are not being captured in typical vulnerability management programs. And RBVM really honestly focuses on that holistic picture of risk. And in fact, we found that when we talk to organizations and when we look at the core products that are in this space, we tend to find that vulnerability really means CVE associated issue as opposed to just a problem. So when we talk about exposures, we're trying to capture the full breadth of that. A full breadth of what can actually affect an asset. So it could be vulnerabilities, it could be missing patches, misconfigurations, permissions and access issues, really anything that you would consider part of the attack surface of a system, we will refer to as an exposure. So I just wanted to lay out some of this groundwork just so that when we talk about the case study, we're all on the same page. So let's dig in. So we talk about this customer. I wanted to give you a little kind of snapshot of this customer so that you understand, what we were trying to do in solving kind of several issues for them in their journey to having an RBVM program. So as a customer profile, so there is, this was a financial organization, had approximately 60,000 assets. This was actually a greenfield initiative for them. So they had never really had any efforts at trying to implement RBVM. They just, they had a kind of an internal discussion and said, this is the new direction we need to go in. And this was also driven by the fact that they had had previous PCI audits. They had had a previous audit the year before, and the auditors had been kind of dinging them for a while, for a couple of audits now, in the fact that they found some lack of maturity in their vulnerability management program. They were getting the job done, but there was room for improvement. So this is where we started, but what the customer wanted to actually accomplish was they, number one, wanted to be able to aggregate the exposure data. So they had several different tools, several different sources of information that were providing vulnerability data to them. They wanted to be able to aggregate that together, make it useful, and be able to kind of fuel their prioritization efforts. Tied to that also was they wanted to be able to correlate exposure data. So being able to look at correlate that exposure data with multiple sources of threat intel. So they were going to use North Star's built-in threat intel, but then they also had vulnerability scan data from other the vulnerability metadata coming from their vulnerability scanners. And once we accomplished those two, they wanted to be able to prioritize based on custom attributes. So adding organizational context for those assets. One of the more interesting things is that this customer also wanted to push themselves out into the bleeding edge. So one of the other initiatives that we had here was deduplication of exposure data. So it wasn't enough just to be able to bring it together, put some threat intel on top of it, and then prioritize it based on, you know, context and other attributes. They even wanted to deduplicate it. And at the end of the day, they also wanted to be able to make that data accessible to a number of different stakeholders and internal processes. So quite a bit of things, you know, of items on this list, but we're going to kind of walk through each of these and talk about, you know, the challenges, and then talk about what we did to kind of address those as we go through. So problem number one, exposure aggregation. So this customer, multiple sources of exposure data. So they had traditional vulnerability traditional kind of network-based vulnerability scanning. They also had EDR, XDR types technologies on endpoints. A lot of those tools have started to provide vulnerability data to customers. So we've had many that have wanted to put that data together. They also wanted to include patch management. So being able to see patches that were coming in and how that connects to the exposure data. And then ultimately, they also had compliance and security benchmark scanning. So they wanted to be able to connect all of this data together and be able to see it and be able to compare apples to apples when they were looking at the data. Now, there were some challenges with this. One was that all of these products have their own rating scales. So, you know, some have severity scales, some use word-based, so like critical, high, medium, low. None of them are the same. So there was kind of a taxonomy challenge there. There was also the simple fact that the classification systems were different. So, you know, obviously a Microsoft KB is not going to be the same as a CVE versus, you know, a vulnerability scan plugin. They're all going to have different ways of cataloging vulnerabilities and issues, and none of them really matched. So this was kind of one of the bigger challenges. One of the other issues they also had was the fact that their attempts to do this in the past were actually pretty much, they were very manual. In this instance, Excel was the tool of choice. And in fact, this is a common theme that we see with a lot of organizations that are looking at implementing RBVM or even just enhancing their existing vulnerability management platforms. Excel is still a vital tool, and that has the pitfalls of being very labor intensive. It's prone to human error. And honestly, in our opinion, it's kind of wastes a lot of time simply because you're taking the security analysts or the vulnerability management people and you're asking them to really do work that can be automated. So these are kind of some of the key problems with that. So when we went to solve this issue, and this was very much kind of the foundation for RBVM, they had a mix of well-known data sources and newer technology. So they had some well-known sources, very easy to kind of work with. They had some newer stuff. So, you know, we can view that. I know this customer looked at things like, you know, like breach attack simulation software, things like that. So they had a good variety of data sources, but to solve problem one, there were three sub problems to this. So one, there was actually automatically collecting that raw data. So the ability to go out, collect it, do it on a schedule, and then be able to ensure that that data is, you know, brought to a centralized location. Also being able to provide structure for that data, because each of these systems is going to have a large amount of metadata. So being able to give a platform for deciding specifically what data you want, and then also having a destination for that data was going to be important. And then also being able to translate that data. So I talked about the idea of different classification systems, different ways of viewing and kind of rolling up these vulnerabilities, being able to translate that into a comparable kind of one-to-one relationship. So To tackle these problems, number one, looking at methods for exposure, for being able to aggregate these exposures. Within a product like Northstar, our customer chose Northstar as its platform to kind of address this. Honestly, most of this aggregation comes down to very simple, basic methods. You're not going to find too much variance here as far as across different products, but it all really honestly comes down to what's the easiest path to get that data. Is it a flat file? Is it a web API? Is it a database import? So being able to import that data in a format you like, being able to make sure that you're able to get that data predictably and on a schedule is also usually pretty critical when we do RBVM implementations. The other kind of sub problem here was the structure. So making sure that there was a applicable technology and applicable, data model to actually put this information in. So that's really where these Northstar super lists came back in. So for the customer, we had already built all that structure for them. In fact, we oftentimes see many customers, if they decide to solve this problem, some of them have gone to the extent of building a solution like this, where they're building all this data structure. For the customer, it was a bonus for them for the fact that this was already it was shrink wrap product. They were able to come in, this structure existed already, and we already had places for all this data. Same with the transformation engine. So the fact that the super lists are kind of built out by this engine, that the kind of horsepower underneath the hood of Northstar provided that ability to deal with the scheduling, the ingestion, the formatting, all of the typical kind of ETL process that goes in with data aggregation and cleansing. That was already available in the product. So for the customer, this provided a very good baseline and foundation for them to build out their information sources. So we actually collect daily from 10 of these data sources. Interesting note is that a lot of customers will start out with multiple data sources, a lot more than 10 that they want to integrate. But we find that once we hit 10, it seems to actually be diminishing returns on what data is either not repeated or is actually useful. But it included a variety of data coming from different places. So obviously your vulnerability data, you got data that sources that provided information about assets, etc. So that laid out the foundation. So that was largely a technological problem of being able to kind of automate all of that process. Now we get into some of the process problems. So problem number 2 here was looking at multiple sources of threat intel. So for customers, they wanted to be able to add threat intelligence from multiple sources. So they were going to use Northstar's built-in intel threat intel feed, but there was also a lot of threat data that was coming from the vulnerability scan product, and they wanted to be able to use both sets of data. Now, when we try to do this type of aggregation for threat intel, what's important here is that threat intel is going to be driving the prioritization process. It is an integral part of it. So we have to be able to figure out how to deal with the fact that there's multiple sources of data coming in. So we can either choose to do a blended method, so we can merge it together, but we may introduce data conflict, and there may be other issues here, and particularly with data confidence. If these sources are in disagreement, which one should we be following? So kind of the other option here is authoritative. So that's basically saying one source is the primary, and the second is used for ensuring that nothing gets missed. So, and if there's particular disagreements. And in fact, that's actually what the customer decided to do. They decided to go with this authoritative method where the Northstar Intel feed was going to provide the primary source, but they were also going to let the vulnerability scanner, if the vulnerability scanner had additional information that would make them want to potentially prioritize a vulnerability differently, they wanted to be able to use it. And that's what we did. And one of the interesting things about that, is, and this was actually another point that is kind of very important when we look at RBVM programs, is when you're dealing with prioritization, it's not just as simple as, I decide this goes into the top and this doesn't. In many respects, it can be that simple, but the ability to have flexibility into how that gets expressed. So the ability to move specific things up and down in a model, be able to prioritize specific assets or specific vulnerabilities, or even specific instances of assets and vulnerabilities. For that, the customer really wanted to be able to decide how much they wanted these attributes to affect prioritization. So we refer to that as gross adjustment versus fine adjustment. So being able to have a dramatic effect. So that's primarily what the North Star Intel feed was doing. But then also being able to have fine adjustments where this other vulnerability scan data was providing that fine tuning, making sure that specific items and specific edge cases were being treated properly in the model. So that was important. Another big thing here is the customer also wanted to make sure that they were future-proofing their threat intelligence. So if a new or better feed came out in the future, they wanted to be able to swap over and use it. And that also potentially included North Star's threat intel feed. And the prioritization model, one of the other things that the customer liked about our model was the fact that threat intel is just another data feed to us. It's just something that we connect in and use. So if they didn't want to use our threat intel and they had another source of threat data, great, we can add it in. We can swap it out, we can blend it, we can do a number of different things with that. But the point here is that the customer got to choose. They got to add and remove and choose what they wanted to put in there. And frankly, any RBVM solution that you're looking at really should allow you to be able to use any data you want. And that was a kind of a key point for them from an architecture perspective. So we've laid the foundation for assets and exposures and aggregation and making sure that we have solid data. We've also layered in threat intelligence. Now we're looking at prioritization. So what can they wanted to be able to use custom attributes to drive that prioritization. So this included things like automatic asset classification. So they wanted to make sure that they were identifying assets correctly. They wanted to be able to adjust the prioritization based upon, it could be based upon something with the asset, the exposure, the specific asset exposure instance. They also wanted ownership of assets. We'll come back to ownership in a little bit, but they wanted to make sure that all of this type of data was able to be assigned to the assets in the environment so that they then in turn could drive their prioritization efforts. What was critical here, though, was also the transparency of it. So it was one thing to just arbitrarily assign ownership. It was another for them to be able to go back and essentially devolve the information so that they were able to understand this final data set looks like this way because of these decisions. And the data was sourced from this location. Because ultimately, this data is going to be scrutinized by both internal and external stakeholders. And it also had to be, they had to be able to explain how and why things look the way they did in the prioritization model. So this was a key thing, and being able to capture those custom attributes, to be honest, they really needed three things to do that. One is going to be that extensible data model. So all of the work that we did with aggregation of exposure data, even of asset data, gave us that foundation already. It gave us the ability to handle data conflict, dirty data, data that needs serious ETL process applied to it. That functionality was already there. What we were really doing is that we were adding additional information and context on top of that. So they needed to be able to have external data. They also needed to have multiple ways to adjust that prioritization. So being able to look at this extra custom data and decide, do I want this data field to drive it in a large way or just in a little fine adjustment in the prioritization. And that ultimately allowed them to, once we could do that, once they had that capability, they really wanted to be able to capture business logic. So being able to capture use cases like when, a system, being able to capture systems that need exceptions or compensating controls or things that, if we know something is going to be decommissioned soon, then it may be of lower priority, things that are not technical issues, but are actual business logic. And this is actually one of the areas where we had probably the most interesting kind of culture shift with this customer, was the fact that most customers, when they try to work in, kind of initiate RBVM programs, they really start with their vulnerability management platforms, and they use those to kind of drive prioritization, or they try to inject that prioritization. So, to put it more simply, they say, here's the data available in that tool. What can I do with it? But interestingly enough, the customer used this project as a way to kind of rethink that process. And they actually looked at it a little bit differently. They said, here is the outcome I desire. So here are the things that I want to be able to pivot on, or I want to be able to use prioritization I want to be able to drive prioritization with. What data do I need to support that outcome? Where does this exist? Or where can I translate it from? And it actually created a very interesting shift in their thought process in their program, because now they were thinking, what their end state was first, and then working backwards from that and saying, hey, this is how I actually want to accomplish, or here's the data that I need to build that end state. So I already mentioned that they provided that ETL process automatically. But one of the things that was interesting is that whenever we build context for customers, and this customer was no different, getting that context is always an iterative process. So it's always something that we there ends up being kind of multiple passes. Now, we usually will, with this customer, we started with a couple of basic data points to work with. So if they wanted to have context, if it's internet facing, or if it's a server, or, simple things that provide kind of immediate value and functionality, gives them some very easy data points. They can drive prioritization with that. But the other important thing was that they had a path to maturity. So while, yes, we were building, we were using these kind of basic data points, the customer was constantly thinking, how can I mature this? What other things do I want to look at? What else do I want to be able to pivot on? And it gave them that path for maturity. They could use it today, but they also could evolve it over time. And that's actually one of the more interesting points whenever we work with customers in general to build RBVM programs, is that the program needs to be agile enough to grow with them, because the context of their business, the relationships that exist within the organization that are going to drive their prioritization are going to change. It's a fundamental fact. So as a result, any tools, any process that you're building around an RBVM initiative really needs to be able to handle that growth. It has to be flexible enough to handle that growth. So that was an important thing. And in fact, when this customer wanted to go get more context, or they wanted to add new fields or provide a new vision or new way to look at this data, all it was as simple as, does this data already exist in North Star? Does it exist in one of the super lists? If not, where does it exist? And these fields came from, previously integrated sources, new tools, spreadsheets, and ultimately the more kind of fun one is employee knowledge and also hidden meaning in additional data. So they leveraged translation and kind of translation functionality in North Star to be able to derive content. derive new data, new fields, new ways of looking at that data. And from there, once they identified where it exists, it was just a matter of building new connections or reconfiguring the existing integrations from the front end to bring in that new data. Transformation engine, we've already put the work in once we did the aggregation to kind of fold all that data together. And then from that point, they're able to drive prioritization. That data is now available. So relatively simple process for them to grow because of all the foundational work that was done thus far. Now, the payoff for this is that the initial results of this process looked something similar to this, where when they were just using their vulnerability data, they had quite frankly an unnerving amount of issues that were up here. In fact, they had about 3.2 million vulnerabilities that were out there, and in fact, the large percentage, about 2.6? No, sorry, off a decimal place. Basically, almost 2 million were considered CVSS highs or criticals, so 7.0s to 10s. Now, as soon as we started applying threat intel to that data, we were able to drive those numbers down quite a bit just by looking at the exploit behavior of that vulnerability. So, already these numbers are dramatically lower. But then as soon as we started adding all that business context in here, these numbers got driven even farther down, so that the issues that they really need to go after, honestly, in this instance, this is about 3.7%, somewhere in that realm, of issues that actually need to go get fixed. But so this was a sharp decline for them. They were very happy to see the results that came up from this. But like any organization that wants to mature, this wasn't good enough. These numbers, while they were interesting, there was a fundamental problem. As soon as we started aggregating all this data together, there was a fundamental problem of duplication. So as we're bringing in exposure data, those numbers I just showed you represented essentially an undeduplicated process, to use very poor grammar. But they said, we want to be able to deduplicate these issues. What they really wanted to push into their RBVM solution is they wanted to be able to look at quote unquote real problems. So getting rid of all this extra noise in the system. So when they tried to do that, there's really two ways to do it. There's simple deduplication, which is just looking at a single source of data and just removing duplicate findings. So, it could be multiple scans of the same asset, historical scans, things that are assets being scanned from multiple network addresses, things like that, where I may have a lot of extra findings that are technically all the same problem. Northstar did this for them automatically. So part of our process of bringing data in and aggregating that data, we did simple deduplication for them. What they were looking for was enhanced, and that was looking across multiple sources and being able to remove those duplicate issues. So to give you an example, when we talk about the issue of deduplication, there's multiple levels to it. The first level, you can look at it where a vulnerability scanner identifies a vulnerability on an asset. That vulnerability is called plugin 1. Plugin 1 is backed by CVEA, and they may have an agent that also finds CVEA. Now, when they aggregate that data, it's going to show two vulnerabilities for the same issue on the same asset. Not terribly hard for us to kind of deduplicate that. But if we bring it up a level, all the same scenario, but there's also saying, hey, their remediation for that is a patch. It's patch X. Plugin 2 shows missing patch. So as soon as you start adding patch data into this, it becomes a little bit more complicated. The net result of this is that when we start adding patch data, we're now seeing 3 vulnerabilities for the same issue. I'm seeing the 2 CVE, that's 2 vulnerabilities, and then I'm also seeing a missing patch finding in there. And then we can bring it up another level where now, yes, we're showing the same CVE on the same asset, the same missing patch, but then also there's an issue where that patch has been superseded. So the vulnerability scanner is showing me that this patch X is missing, but the patch management system saying that actually patch Z, which is a roll-up of patch X, is the one that's actually missing. So we've seen instances where, in instances in this particular customer, where they were showing 4 or more vulnerabilities for the exact same real issue on the asset. The fundamental problem is there's a vulnerability, but the way that we were aggregating all this data together, it was showing a lot of extra vulnerabilities. So there's really kind of 2 ways to solve the problem with that problem. You either can take all the exposure data and convert that into an independent system of tracking, so an RBVM exposure ID, if you will, so normalize all of them, or you take one classification system, make that authoritative, and convert everything else to use the authoritative one. And that's actually what the customer decided to do. They decided to convert all of them, all the other exposures, to the vulnerability scanner scale. So in order for us to do that, we broke those vulnerabilities out into three categories: vulnerabilities, missing patches, config issues. And for each category, Northstar processed those individually because there was going to be data coming from different places for that. So for instance, with vulnerabilities, we were getting it from the vuln scanner and the EDR XDR solution. For missing patches, it was coming from the vuln scanner and the patch system. And for compliance, it was that, and then the vuln data, and then the compliance benchmarking. We processed each of those individually, and for each of those exposures, we went back and looked at the CVE values and the CPE values to determine where we could find matches. And once those exposures were in the same format, Northstar's basic data process was allowed it to deduplicate that when it was building out the super lists. But this was not without its challenges. I've made it sound, I've made it sound like no big deal. There are some things to know about this process. One is that not every exposure is tied to CVEs. So there could be things correlated. If it couldn't be correlated, at the bare minimum, we're at least providing additional information from the vuln scanner. We also had if there was no obvious deduplication, Northstar was also using fuzzy match logic. So we were looking at CPE values, family values, and making sure and figuring out if we could deduce what was a likely match in that system. We had got a lot of feedback from the customer here on their preferences on how it should work and how they want to see the data. But the basic idea is that we were able to dedupe even more to be able to see, to get more matches and find where there likely was a match. Now, that being said, most of the data lined up. Most vulnerability scanners, we tend to see a single plugin targeting a single CVE. Patches were probably the most challenging due to supersedence and patch rollups. But the other interesting thing about this is, and this was something that the customer wasn't necessarily prepared to see, the fact that the deduplicated data is actually decoupled from the raw exposure totals. So they were looking to kind of compare the original totals and then look at the new content and be able to see that connection. The problem is that as soon as we're condensing vulnerabilities down and deduplicating them and only bringing in one issue for something that's represented multiple times, the totals don't match anymore. So it was kind of another kind of culture thing that they had to, think about if that was, if that's how they wanted to see the data. But to give you an idea of what that looks like, I showed you the original results. We came with 3.2 million vulnerabilities. When we ran it through this deduplication process, it actually pushed it down to 702,000. So that was essentially combining anything that we could combine together. And it looked basically like this, where the original total was a lot lower, but now when they started applying that whole RBVM process, you started seeing some very small numbers here up at the top. And this is where they started to really see the value and really get some good meat on the bone of saying, yeah, this is a reasonable number of issues that we can go fix today. So deduplication was, while it's not totally necessary, it ended up being very compelling for this customer, particularly in driving this prioritization initiative. So lastly, and probably one of the more kind of basic issues, is that they need to be able to report to a variety of stakeholders. So this could be, obviously the technically focused people, so security vulnerability teams, remediation teams, but it also included leadership, C-suite, risk teams, auditors, and then also ticketing system. This is actually one of the more interesting parts of this, and I'll talk about it in a second. But North Star gave them a few different ways to do that. We had traditional dashboards, so the ability for you to look, to be able to capture data, be able to make it interactive, view reports. So that solved that problem. We were able to get some very good reporting for the different variety of audiences. And we also had an API, so being able to make this data accessible in a variety of formats, whether it's an actual report or a dashboard or just an API endpoint, was also important to the customer. They wanted to make sure that however they wanted to use the data, that they had the capability to do so. And it's that API that we actually use to kind of close, to push the RBVM program even farther. They wanted to push into a ticketing system to create new tickets, update existing ones, and reopen closed tickets if we still saw an active result in the vulnerability data. So we actually took, because of all of the kind of built-in functionality within North Star, we use that to automate those API calls. So every day they are pushing new vulnerabilities in, they're updating existing tickets, and that includes all of the metadata that we've also collected. And in fact, we're currently managing about 600,000 tickets for them daily, as far as updating that process. But the biggest thing to take away from this is that their ticketing process was actually very manual. And it was actually a bonus win for the customer, because when they started, they had over 2 million tickets in the ticketing system. But once we deduplicated it, the exposure data, we actually looked at the real issues that were out there. We found it was actually 600 to 700K issues that actually needed tickets. And that was for a variety of reasons. There were a lot of dead tickets, so things that were opened and forgot about, orphan tickets, remediation teams forgot to close tickets, duplicate tickets were in there. So it actually, just by approaching this process, they were actually able to dramatically reduce the bulk of their ticketing system requests, simply because they were only pushing in a single instance of a single problem into the ticketing system. And lastly here, another important thing for them was PCI audits. So being able to make sure that they were able to demonstrate to PCI auditors that they are actually putting in a system that works, and then also is explainable. It's transparent, that it's able to be understood. And in fact, once we brought all this data together, we deduplicated it. If we focused only on PCI devices, this is essentially what the customer showed PCI auditors. And explain the methodology of how they were deriving organizational value and criticality, how they were adjusting the tickets, how they were deduplicating it. And the fun part about that was they very successfully were able to navigate PCI audits. And the auditors even made a special note of saying they praised the clarity and the maturity of the customer's RBVM process. They were able to look at it as outsiders, able to understand what the customer was doing, and more importantly, the customer was able to explain it to them. It wasn't just a black box as far as solving problems. So, as a quick recap here, when we talk about the lessons learned, I wanted to just put an end cap on this to talk just a little bit about, what were some of the bigger things. Bigger things here is that customers have the data they need to do RBVM already. That tends to be one of the more interesting challenges when we initially talk with any customer. There's a lot of hesitancy to say, yeah, we've got that data. They do. It just requires to, we just have to, spend a little bit of time doing that research. The other piece that's very important is the flexibility of the RBVM platform. So yes, being able to do the prioritization is one thing, but then also being able to make sure that that platform can grow with the needs of your RBVM program. Another big thing for a lot of companies, particularly ones where this is greenfield initiatives, understanding the desired end state. So what attributes do you want to drive prioritization? How many tiers do you want to have in prioritization? So, how many, is it an instance where you only, it's three severities, or do you want 5, 10, whatever? Having a good understanding of what your end state is allows you to work backwards and allows you to build out a program that's frankly a lot more robust because you're building it with intent. And that being said, that process is iterative. So one of the early expectations that we encourage customers to set internally is that any program, regardless of the technology, regardless of anything you're doing, it's gonna take some time to mature it to where you where you want it to be, that end state. You can get a lot of value early, but it's an iterative process. You need feedback, and you need to be able to make sure you're capturing all the edge cases. So it's important to set that expectation internally. And the last piece here, automation is key. Every customer we've ever worked with, let the technology do the easy, repeatable stuff. That's fundamentally where North Star, one of the big early benefits is. It frees up the resources you have to be able to let them do more interesting and frankly more useful stuff for the organization. They're not wasting their time in Excel trying to merge data. They're not instead looking at vulnerabilities and making important decisions about how the organization should respond. So these are kind of some of the larger points that we have. But that ultimately brings us to the end of our discussion here.
Kevin, thank you very much. We have a couple of questions.
Sure.
The first question was just about the most recent topic you were talking about, around dead tickets. Does that mean fixing vulnerabilities?
It can. It can mean a few things. It can mean an instance where a vulnerability has been fixed and perhaps, nobody closed the ticket, or even, nobody went back and validated. That was a pretty common thing that we saw with this customer, that somebody had actually fixed the problem, but then they needed to have a vulnerability scan to validate it. And that validation either never happened, or the data that was necessary to validate it never made it from the vulnerability scan system. So that could be an instance of dead tickets. A lot of them, honestly, we saw where they have been sitting there for 6+ months and either weren't getting fixed, and the customer frankly just lost faith in the fact that this was still a real problem. So their thought was, in essence, honestly, what we ended up doing was we essentially used a brand new ticket queue and put those new issues in, and effectively the customers rebooted their ticketing just to make sure that issues that were coming in, we knew we had validated them as real problems. But yeah, that's actually a very interesting topic in terms of ticketing and how to deal with that.
Okay, second question. How does North Star address the issue of poor CMDB quality data, or the quality of the CMDB data?
Well, the simple answer to that is I've never met a customer that has good CMDB data. So there's a couple of ways to look at that. One, in North Star, we expect the data to be dirty. We expect data that we're importing to have issues. We know it's going to potentially be dirty, incomplete. So we'll still bring in that CMDB data. What we typically find is that CMDB data just tends to be stale. It's not that it's outright inaccurate. It just tends to be stale, which in turn makes it inaccurate. So we'll bring that data in. but we don't treat really any source of information when it comes to building vulnerability, exposures or asset data out. We really don't treat any of them authoritatively. There's a concept here, I didn't have time to get into it, but there's a concept when we build data sources, we have the ability to set confidence levels for that data. So it could be done at the source level, it could even be done at the field level. But we can decide if that data, I can still bring in that CMDB data, but I may choose to put it at a lower confidence level and say, yeah, I'll take it if there's nothing better. So if for fields, there may be instances in fields that are only coming from the CMDB and it's the only data I have. But at the end of the day, we solve that problem oftentimes by the fact that we are pulling this data from multiple sources of information. And interestingly enough, a lot of customers, once we have aggregated all that asset information for that, we'll actually feed that back to the CMDB for updates. That's a very common use case for us, where we will enrich, we will take their potentially incomplete data, fill it out, and then send it right back to them. And we'll keep doing that in a continuous loop so that the CMDB team gets the benefit of getting validated, updated information.
All right, next question. Did the prioritization have any impact on their PCI audits?
Oh, for sure. It's one of the more interesting things about this when you talk about prioritization. The challenge that they had initially was that when they were doing their regular vulnerability management, PCI auditors would walk in and they would look at the number of vulnerabilities that were sitting in the critical and high field, and they would keep telling them, there's too many here, you need to fix them. But you also needed to have a process for validating that these are issues. Because one of the challenges is the PCI auditors are not blind. They understand a lot of the issues that I said the customer was trying to solve with things like deduplication. They know it exists. So prioritization absolutely helped them because it allowed them to focus in on, number one, they still had a lot of vulnerabilities. They had a lot of vulnerabilities out there, but when we focused only on the PCI devices, they were able to show, here's the process we're taking on how to triage those issues for PCI devices. We know we need to fix them, but here's what we're doing. And for every single issue that showed up in a critical or a high stance, they were able to either show that they had mitigated the issue, so they had cleaned it out, that they had an active action plan to go fix that problem, or that they had moved it down in priorities so that it was either granted an exception or there was a compensating control in place. And every single one of those things, with prioritization, in North Star's prioritization model, every single one of those things was transparent. So PCI auditor could pick on any issue, and the customer was able to just go, yep, here's what we're doing for that. Here's how we're addressing it. Here's how we prioritized it. Here's the data that went in with it. And that oftentimes changes the vibe of the audit, simply because, the finding, they still had some critical vulnerabilities on PCI devices that they were fixing. But what they were giving the auditors confidence on was the fact that there was a process in place, it was repeatable, and that it worked. So that changes the tone of the audit quite a bit, because now the PCI auditors have faith that these issues are going to get fixed, and that they're seeing that the organization has embraced a process that will get them to where they need to be. So it's a fundamental shift for a lot of organizations subject to those types of audits.
Kevin, that's it for the questions today.
Oh, excellent.
Well, thank you very much for everyone for joining this afternoon. We will share the recording with everyone that has participated, and that will be coming out in the next 2 days or so. And if you have any questions whatsoever, please let us know following that. Thanks again. Have a great day, everybody. Thanks, Kevin.
Thank you.
Bye-bye.